I'm in a 4-year term as president of the Federation of European Nutrition Societies, FENS. FENS is an umbrella organization for 26 national nutrition societies in Europe, going from the north to the south, the east to the west. And FENS really exists to support the activities of the member societies. I have a presidential activity which is around improving the credibility of the science of nutrition. Connie touched on that. That activity involves members who were nominated by the 26 member societies, and it also includes members like Connie, and Sylvia has been a little bit involved, who are representing the American Society of Nutrition, and also the Nutrition Society of Australia is involved in the activities. At the end, I'll come a little bit to what we're doing. Connie already touched on that, and actually some of my slides overlap with Connie's. I've really enjoyed this meeting, but there was one really frightening talk for me. And that was the talk by Danawak Tiensen. That was an excellent talk on steps planned needed for sustainable food systems in Asia Pacific. Why was it frightening? I have 4 verbatim quotes from the speaker. We need the science. Science will tell us the facts. We need the scientists to help us, and science will tell us. That's putting quite a burden on the scientists. And what we do has to be credible, because that's the expectation. Those quotes tell us the expectation. So this is how I compartmentalize the components of nutrition science. We have observational epidemiology, usually in medium to large population cohorts. This could be cross-sectional studies, longitudinal studies, whatever, retrospective studies. We have intervention trials. Connie's talked a little bit about randomized controlled trials. And we have what I've called discovery science, which is mainly what Hani was talking about, not exclusively. So let's call that preclinical science. It could be human related, but it might be animal work, cell culture work, or what have you. Personally, I see these as all part of a continuum with the different elements linked to one another. And none of them, I think, can exist in its own right. We actually need all of these things to gather our evidence. So together they produce the evidence base, and that evidence base is mainly used, well, some of it is just generating knowledge. That's important for our culture and society, but practically used for recommendations and policy. And the way we judge this evidence is typically captured in these sort of pyramids, where we stack up the quality of the evidence going from the bottom to the top. So down the bottom, we have what I called the sort of epidemiological, observational type studies. Then we have the gold standard randomized controlled trials. And layered on top of that, we have the meta analysis of this evidence. So that's our hierarchy of evidence. And of course, whatever you're doing, you want it to be as good as it can be. So if you're doing trials, you want the trials to be as good as they can be. If you're doing observational studies, you want them to be as good as they can be. But that is the way the hierarchy is seen. And of course, that hierarchy is based on medicine. So if we apply this simply to nutrition, we're really medicalizing nutrition. And I think that's something to keep in mind. We work by the rules of medicine by and large. So if we want robust recommendations, robust policy, we have to have a credible evidence base. And a credible evidence base requires fit-for-purpose methodologies and robust study conduct. And Connie was really talking about making our study conduct with randomized controlled trials at least more robust. So that's clear. Standardized approach to science, that's also been touched on. How can we compare different studies? How can we weigh them up if they're not conducted in a standardized way? Personally, I think we need to recognize the entirety of the evidence and weigh that up. And in doing so, we have to appreciate the true strengths and limitations of the different contributors to the evidence base. And to do all of this, we need funding, a competent workforce, and the infrastructure support that is commensurate with the importance of the problem. So if the problem's not important, we don't need too much funding, we don't need too big a workforce, etc. But if the problem is important, we need the funding, we need the workforce, we need the infrastructure. So as I mentioned, there's a little bit of overlap between what Connie said and what I'm saying, but let's look first at fit-for-purpose methodologies, study conduct, standardized approach. And ILSI Europe, I think particularly, has made significant contributions here over 2 decades. For example, a lot of work done around validated biomarkers, the sort of outcomes that might be measured in different types of human studies. So markers of glycemic exposures, markers to measure immune function, validation and selection of cognitive tests, things around devices and technology, good conduct of human gut microbiota, and an overarching view of biomarkers. So these, I think, are pretty significant statements about biomarkers, validation, robustness, and what have you. This is an image from one of the ILSI Europe expert reports around markers of immune function. It doesn't really matter, it could actually be markers of anything, biomarkers of anything. And we spent some time trying to work out how you might interpret a change in something you might measure, for example, in a laboratory. So if you have a normal range in the population and you have an intervention and you change the number that you measure in the lab, you know, from here to here or here to here, even if it's statistically significant, what does it really mean? How do you interpret that? You've just moved something within the normal range. Of course, you get a statistically significant effect and you publish your paper in American Journal of Clinical Nutrition and you're very happy. But you know, what does that really mean? You can have other things where you might start outside of the normal range and have an intervention that brings the number into the normal range. That's probably going to be meaningful. You might have an intervention which takes you out of the normal range. That's likely to be meaningful, but is it desirable? You might have something which over time, for example, with aging, moves from being in the normal range to being out of the normal range, and you might have an intervention which stops that movement out of the normal range. And of course, there's a lot of focus around healthy aging with interventions that do exactly that sort of thing. So this is sort of just, the detail doesn't matter, just that there are people who have been thinking about how we interpret the findings of our well-conducted randomized controlled trials. As Connie mentioned, ILSI Europe also put some effort into, over 10 years ago now, into things around the design, conduct, and reporting of human intervention trials. And Connie mentioned the NIH-funded activity with these papers, all published in 2021, around the different components of everything from design to analysis and what have you. So that's all good about making our trials more robust if we're doing trials. Connie's mentioned Consort, the Consolidated Standards for Reporting Trials. Consort began around the reporting of drug trials. So it's designed for the medical community. And you'll be familiar with these sort of flow diagrams of participants through a 2-arm randomized controlled trial. Connie has mentioned the 25-point reporting pro forma that's used. Again, I'm stressing this is designed for drug trials. Of course, people do trials in other areas, including nutrition, psychology, we heard about, physical activity, and so on. So people have sought to extend Consort to take into account the uniqueness of some types of trials. So, for example, in a psychology trial, there might be things that are really important to be reported that don't feature on the 25-point reporting pro forma for a drug trial. So there are extensions. So there are extensions for other types of trials, for example, for multi-arm randomized trials, for other types of trials. There are extensions for other types of data, but the key thing is the extensions for non-drug interventions. So these are the Consort extensions. So there's an extension for herbal medicine trials. Okay, so if you're doing a herbal medicine trial, there's a Consort reporting scheme for you. Actually, if you're doing Chinese herbal medicine trials, there's one for you. If you're doing an acupuncture trial, there's one for you. That's amazing. What about the poor nutritionists? We don't have an extension. Why is that? Why does acupuncture have an extension and nutrition doesn't? Why does Chinese herbal medicine have an extension and nutrition doesn't? Well, nutritionists have never done anything about it. It's our fault. So one of the things that Connie is leading on in the FENS activity is trying, and she listed the group, trying to develop a nutrition extension of Consort. Okay, that's a long story how to achieve that, but I think we can do that. So that will be a step forward. We will have a reporting scheme that hopefully will be taken up by the community for our trials. Now, next thing is recognizing the entirety of the evidence and appreciating the true strengths and limitations of the different contributions to the evidence base. So randomized controlled trials can establish cause and effect. You do something to somebody and you look at the effect of that. That is why they're the gold standard. But in nutrition, this can be problematic. And last time I showed this, which was 2 weeks ago, someone got very upset with me. But the main thing we do in my lab is randomized controlled trials in people. So I'm not against trials. We do them day in, day out. We register our trials. We do all of those things. But in nutrition, it's very difficult to achieve the naive state. The placebo can be difficult to identify. Blinding can be difficult, particularly with a food type intervention. Okay, it's okay with a supplement like omega-3s, you can blind that, you can do all sorts of exciting things. Often our trials are small and short, okay? The effect size can be small, someone else has mentioned that. That doesn't mean it's not important, but it does create issues around sample size and power and so on. The individuals we study may not actually be representative of the population we're interested in because of inclusion-exclusion criteria and so on, because we're using the medical approach. The effects of the active, of course, can involve interaction with other foods, nutrients. Good examples from the vitamin D arena, where vitamin D works differently if you give it alone or you give it with calcium, for example. There are lots of those sorts of things. So studying nutrients in isolation can be a little bit problematic and may not represent anything to do with a food. Of course, you have variable responses related to background diet, body composition, physical activity, genetics, gut microbiota. We've heard about some of those things. So they can be problematic. But nevertheless, we say they're the gold standard. They sit on the top of our pyramid, and that's what we work to. Now, this is the UK Dietary Advice distilled to a simple image for communication with consumers. So we see on here the things we should eat in abundance, the things we should eat in lower abundance, and so on. So this is the recommendation. Where are the randomized control trials for all the things on this plate? Well, there aren't any for most of them. So the recommendation, based on apparently the highest level of evidence, actually isn't based on randomized controlled trials. It's based on other things. A lot of it is observational epidemiology. So actually we value observation quite highly in nutrition because that is the basis of most of our recommendations because we lack randomized controlled trials. This is an interesting paper by a group of individuals from the UK. It's published in British Journal of Nutrition last year, considers the methodological advances made in nutrition epidemiology and frameworks used by expert groups to support objective, rigorous, and transparent translation of the evidence into dietary recommendations. This is a very thorough and interesting evaluation. They talk about the Bradford Hill characteristics for causality in the context of epidemiology. So this is pretty interesting, and it relates back to what I just said about dietary recommendations mainly being based, at least the scientific bit, being based on observational epidemiology. So far, I've showed you, I think, the same pyramid twice. There was something really important missing from those pyramids, and that is basic science. Because I think you need plausible mechanisms to explain the effect of any nutrient or food. So basic science is really important to developing recommendations and policy because you have to understand how things work, okay? You might evaluate the value of that differently, but it's still part of the picture. Nevertheless, we're hung up on pyramids. But people have questioned, actually, is there another way to stack up the evidence base that isn't a pyramid? And these are just two examples. Well, one of them still uses a pyramid. It actually relates to Alan's question from earlier. But one of them is a circle. These are not from nutrition. But this is saying, here's the evidence around here, the different types of study. This is what those studies tell us about, and that's how we might evaluate things. So we don't say one is better than the other, one is more important than the other. We actually use the totality. We still have a weighting, but that weighting might be different in different situations. And I think the title of this paper is something like, yeah, is the evidence pyramid now dead? Well, obviously it's not, but that was a proposal. I really found this an interesting paper. So this is the pyramid that I've been talking about, but what they've done here is suggested one alternative where rather than these straight lines, there are wavy lines. And what they're trying to communicate is there might be some cohort studies that are actually more valuable than randomized controlled trials. And there might actually be some case control studies that are more valuable than cohort studies. So it's saying, let's look at the evidence in a slightly different way. Let's not say something is better just because of the type of study it is. And of course, it still has the systematic review and meta-analysis on the top, but they actually suggest another model where you don't place those on top, you use them as a magnifying glass to look at the whole of the entirety. So I think that's pretty interesting as well. We've heard about the grand challenges, the aging population, climate change, the double burden of malnutrition, food system transformation. These are all related to one another, and we've talked about all of those during the meeting. We, as nutrition scientists, are expected to play a part in overcoming all of these challenges. Okay? Thanawat said, science will tell us the facts. We can't do that on our own. And that's because we need to link with other disciplines to answer these big questions. This is a picture from mainly Dutch consortium, pointing out the need for an interdisciplinary approach in nutrition science. We need funding a workforce and support commensurate with the importance of the problem. And the problems are big. And our contribution to these problems, these challenges, is assumed to be an important one. Therefore, we need the funding, the workforce, and the infrastructure that is expected of us. Now, the last thing is who uses the recommendations and the policy? Well, the two big users are, of course, consumers and industry. So we have to communicate, we have to disseminate our science to the end users. And scientists like to do that. But I think the reality is the communications of findings from nutrition research is poor. And earlier in the meeting, we had a really good example about red meat, where analysis of the same data set gave two divergent conclusions. Meat is bad for us, meat is harmless. And that was, I understood, just simply about the statistical analysis approach to the data. So these are my examples, or my example. Up to 25 cups of coffee a day is safe for heart health. Study finds. So this is some researchers did a study, put out a press release, it's in all the newspapers, whatever. Up to 25 cups of coffee a day, safe for heart health. Heart danger of 4 cups of coffee a day. Other researchers did another study, released a press release, taken up by... These two things probably cannot both be true, right? There might be an unusual dose-response relationship, but unlikely. It's more something to do with the experiments, the analysis, what have you. This is another California judge rules that coffee requires cancer warning. So, you know, this is serious stuff. So what it means is the people out there don't know what to believe. They're confused. They distrust us. You know, these people don't know what they're doing. They actually don't care anymore. That's a big problem for us. And they listen to advice from poorly informed experts. Someone showed a slide where they had the power of the influencers. That's where people get their nutrition information from, not from us. So we have to do better, no doubt about it. So we need to think about and improve our concepts and our methodologies. Methodologies, we're actually making advances, that's clear. But what about our concepts? Are there other approaches we can use? We need to think about how we organize ourselves, how we fund ourselves, what our capabilities are, and we really have to think about how we communicate with the public and how to get better trust in us, how we can be taken seriously. So I'm almost at the end. So as I mentioned at the beginning of the talk, in 2019, when I became president of FEMS, I started this presidential activity. Sometimes it's called improving or improve standards in the science of nutrition. Sometimes it's called ensuring trust in nutrition science. They sort of mean the same thing. It means us getting our act together. So we have 3 working groups. Connie is part of a subgroup of working group 3, but our 3 working groups are working on concepts and methodologies, organization capabilities and funding, and external communication and public trust. Probably the first output we will have will actually be guidance for nutrition scientists about press releases, okay? Trying to get people to be more, I'll use the word honest, and convincing your university press office that you need to be honest in what you say. Give a proper evaluation of your study, okay? So you've done a cell culture study, you haven't cured cancer, right? But that's what the newspapers are full of. Okay, boffins discover cure to cancer, right? So, so we're starting to get towards finalizing some of these things. We're going to have meetings at IUNS in Tokyo. So if you're at that meeting, come along. We have a symposium. We're going to have a workshop, and we're going to wrap all of this up by the end of my term, which is November 2023 in Belgrade. So take homes, Nutrition science is expected to play its role in meeting some of the important challenges of the early 21st century. There's no doubt about that. People keep telling us that. Right now, we lack credibility and capability, if we're honest. Existing medicine-based paradigms for evaluating the evidence may not be best suited for nutrition, or they might not be the only solution. They might be part of it. We need to consider other things. There's been a lot of focus on improving the qualities of randomized controlled trials, no doubt about it. We need to think about the other things I mentioned, and we have this activity that's going to try to help with that. Thanks very much for your attention.
Thank you, Philip, for an extremely stimulating talk. And I think the field of nutrition is more alive than ever. It's just extremely important to see ILSI being in the middle of this, right? So we will have more talks in the afternoon, indeed, about challenges in nutrition and how to merge that with sustainability debates. There's food safety, which touch upon everything what you mentioned. So I guess the floor is open for questions. I'm expecting a good debate. Louise, please go ahead.
Philip, yeah, really nice talk. Very stimulating. One of the things that was constantly at the top of your pyramid was systematic reviews and meta-analyses. And it's sort of a comment as well as a question, because obviously the quality of those systematic reviews and meta-analyses is absolutely predicated on the quality of the trials that feed into them. And I think there is a bottleneck, if you like. I've been very vocal at ILSI so that we moved away from narrative reviews where possible into doing systematic reviews, partly because those carry far more weight and we can draw stronger conclusions from them. But there is that bottleneck, and I wondered if you wanted to comment on that because of the fact that if we don't have the quality of the trials that meet the criteria to be included in the systematic review, we can't really draw those strong conclusions.
Yeah. I think there's two comments. One is I agree with you. So the literature is full of systematic reviews of nutrition that are based on poor studies. So that's the first thing. The second thing is the idea of a systematic review is, of course, it's systematic so that no matter who does it, you get, in theory, you get the same answer, okay? Personally, I don't think that's true. And the reason I don't think it's true is a lot of people who do systematic reviews in nutrition don't know about nutrition. And I have reviewed dozens of systematic reviews on omega-3s and every possible outcome there is. And those people they include studies that are not about omega-3s. For example, I've had some that included studies of conjugated linoleic acid, and they included CLA, get this, because they think CLA is healthy, and therefore it must be an omega-3 fatty acid. That has been a common response. So people mix things up a lot. So you get, and you know, you need, I mean, the reason I always accept to do these, although it's quite burdensome, is I always think if I don't look at this, someone else may not pick up what they might see as a minor thing. The other thing in the omega-3 systematic reviews is people, 9 times out of 10, they make a mistake with dosing. Because most people think a 1 gram fish oil capsule is 1 gram of omega-3s. So every table with the dosing in some systematic reviews is wrong. And the people don't realize that. So if you don't have some expertise in, I think, in the discipline, and I know about nutrition, but it might be in psychology, it might be in physical activity. If you don't have some expertise in the discipline, personally, I don't think you can do a robust systematic review.
I'd like to follow up on that, because as I've reviewed lots of reviews, given we get 400 a year or 500, I think that they're being used incorrectly in one regards. They look at the forest plot and they want to know what the average adjusted odds ratio is, and that's all they look at. we have this object. They don't look at the differences between all the papers. And that's really the value, I think, of a meta-analysis. Is why were these studies different?
Yep.
Not just what the average is. And we have very few discussions in our papers, and
Yep.
say, even as the editor, people are saying, why do we have these variations between studies? And I think now as I think about this more, it should become a requirement that when you do a systematic or a meta-analysis, you discuss why the studies are different.
I think a lot of them say, you know, there was a high level of heterogeneity, and they stop at that. Yeah. So I think you're dead right. Yeah. There's a question.
Or is it me? Yeah, thank you very much, Philip, for a mind-boggling presentation. And you mentioned that people believe more the nutrition influencer on TikTok or something like that. But is it possible that something is missing from the foundation of training of the nutritionist? So if my boss stopped me and gave me 30 seconds to talk about nutrition, would I rather talk about statistical significance, or would I talk in a humanly understandable manner? So my question is, can we go back a step before and ask ourselves, can we train people more on how to communicate nutrition, and also to probably talk less about malnutrition and talk more about nutrition, the positivity part of it? Thank you.
Yeah. Thanks very much, Victor. I think that's a really important point. So one of the things we've done, well, I say we, I wasn't involved, with the guidance around press releases is sort of along the lines that you are talking. It's sort of guidance about how to communicate science in obviously a meaningful way, but in an honest and transparent way. So what are the, you know, in what you can do, you know, what are the strong points about my research? What are the weak points? What does it actually mean? So I think you're right. More training in communication of the science I think is necessary, for sure.
I have a couple of questions here in the front.
That was a great talk. I was curious about the pyramid that you were showing, which is putting, you know, randomized control trials at the top, and then case studies or N of 1 studies, I guess, at the bottom. And I think there's sort of this irony when we launched this ILSI symposium yesterday. The first presentation from Dean Ho was about the value of N of 1, and the fact that we are talking about precision nutrition and personalized nutrition and precision medicine and personalized medicine, and the hierarchy still is that we want to do large-scale trials assessing whether there's a net effect or benefit. And even in drug trials, even the best drugs have no effect on more than 50 or 60% of people. And I think, you know, are we putting too much emphasis on RCTs as being the way to go forward? And should we really look backwards and downwards at these N of 1 type studies?
Yeah, you're dead right. So that's what I mean by looking at our concept. So what's the best portfolio of methodologies for us to adopt? So, you know, N equals 1 trials could be very important, for example. There might be other study designs that are very important for us. So I agree with you. And I think we're stuck with the pyramid because, you know, our science became medicalized quite early on, you know, in the 1960s, I guess. And some of that has been good, but I think we have to sort of evolve the way we do our science.
So a nice note to share is about a week ago, the FDA commissioner, Rob Califf, told the science board it's more exciting to be in food nutrition research right now because of precision medicine and omics everything that's going on than it is in drug discovery.
I think that's a very nice comment to end the session with, isn't it? So I don't think there are any questions, comments from the people online. No? Okay, then we have just one final one.
Thank you very much, Philip. That was very nice. I just had a more general question also in one of the earlier slides on ILSI. It's access to information or documentation. And thinking about it all, I thought this is such a critical part. And, you know, in the ideal world, we would have access to any information of published studies, whether it's preclinical, epidemiological, or clinical, because when different researchers look at the same amount of data or the same data, they may come to different conclusions, like the coffee studies. And it would be wonderful if different researchers could have access, well, and just give their viewpoint on the same data set. And I think what we're missing, all you see in a scientific paper is in the end, you see one graph and a few things and a conclusion, but you know, all the other work that's gone behind there, you don't see. And I thought, you know,
I think there's an easy answer to your question. So of course, in days gone by, people didn't want to do that. They said, you know, this is my data, I'm not going to show it to anyone else. But things have changed, and there is a requirement for making data available. And we have to play by the rules that surround us. And so it's more common, or becoming more common now, for nutrition research to make its data available through you know, the sites that are set up for data sharing and so on. And, you know, a lot of funders require, you know, open data now. They require us to make the data available. I think, you know, sometimes we're a little bit slow to catch on, but it will happen over time. So we will get there.